Example 7.9 is going to show us that the quotient rule is nothing more than the product rule. So if you can't remember the quotient rule, you can get it from the product rule. And then we're going to see that in action. So this first part, let's figure out how the quotient rule comes from the product rule. We are looking for a way to differentiate f divided by g. So before we differentiate, I'm just going to rewrite that as f times g to the minus 1. And understanding that g to the minus 1 is not the function inverse. Right? If you have a function g that maps x to y's, g to the minus 1 is not the function inverse. It's literally just 1 over g. But now we have a product rule. And how do we differentiate products? We differentiate the first term, we leave the second term alone. We add to that, we leave the first term alone, and we differentiate the second term. The first term looks great. And when we differentiate g to the minus 1, we have a chain rule. So the minus 1 is going to come down. We have g to the minus 2 now, and then whatever the derivative of g is. All right, rewriting this, f prime g to the minus 1 minus an f g to the minus 2 and a g prime. And rewriting this once more, f prime over g minus f g prime over g squared. And I said once more, let's rewrite it once more with a common denominator. So we have f prime g minus f g prime over g squared. So this is low d high minus high d low over low low. All right, so let's apply this. Let's differentiate the rational function x squared minus 1 divided by 1 minus 2x in two ways. We're going to do our quotient rule over here. And here we're going to use the product rule. All right, so differentiating this, we first have to rewrite it. Y is equal to x squared minus 1 times 1 minus 2x to the minus 1. And the product rule tells us differentiate the first term, leave the second term alone, plus leave the first term alone, and now differentiate the second term. So it's going to turn that plus sign into a minus. 1 minus 2x now to the power of minus 2, and then times the derivative of 1 minus 2x minus 2. Okay, let's rewrite this. This is now 2x over 1 minus 2x. And I'm going to square that, and I'm going to give myself another one up top. So I didn't change anything. I moved this guy down, and then I gave myself an extra one down there, but also an extra one up top. Effectively, I know I'm going to need a common denominator. And then over here we have a plus, because of that negative and this negative, a 2 times an x squared minus 1 over a 1 minus 2x squared. All right, simplifying this, we end up at 2x minus a 4x squared plus a 2x squared minus a 2 over a 1 minus 2x squared. And we should simplify that once more. 2x. In fact, I'm going to order my terms. How many x squareds do we have? Minus 2 of them. We have a plus 2x, and we have a minus 2. Okay. So you could, if you don't remember the quotient rule, use that product rule. But now, if we understand the quotient rule, y prime is going to be low d high minus high d low over low low. And by simplifying this, we end up at 2x minus a 4x squared plus a 2x squared minus a 2 over 1 minus 2x squared, which by simplifying and ordering our terms, we have minus 2x squared plus 2x minus 2 over 1 minus 2x squared. And I think that's the same thing as we got over there.